Ignition sequence start.
Good morning and welcome to Mission Control Houston. You're looking at a live view inside the International Space Station Flight Control Room, where there's a team of specialists on duty 24/7 to keep tabs on station systems and assist the Expedition 60 crew members with their science and maintenance tasks. Now, along with that standard work this week, Commander Alexei Ovchinin and his crewmates have started getting ready for the next crew rotation, which kicks off next week with a Soyuz launching to orbit carrying a tri-national crew.
Welcome to Space to Ground. I'm Isidro Reyna. This week, launch updates to the station and more. A Japanese cargo spacecraft scheduled for launch to the International Space Station has been postponed. The initial launch of the JAXA H-2 transfer vehicle was scrubbed on September 10th due to a fire on or near the JAXA launch pad. See the latest updates on the launch status at nasa.gov. The next crew to launch to the station is at the Baikonur Cosmodrome in Kazakhstan for final mission training. Expedition 61 crew members Jessica Meir of NASA and Oleg Skripochka of Roscosmos will blast off on September 25th aboard the Soyuz MS-15 spacecraft with spaceflight participant Hazza Ali Al-Mansouri. The trio from the US, Russia, and the United Arab Emirates will take a 4-orbit, near 6-hour ride in space before docking to the station. Al-Mansouri will return to Earth on October 3rd aboard the Soyuz MS-12 spacecraft with NASA astronaut Nick Hague and Soyuz commander Alexei Ovchinin of Roscosmos. Mir and Skripochka will orbit Earth until the spring of 2020. As NASA prepares to send the first woman and next man to the moon, Brad Pitt is playing an astronaut in his latest film. The actor called up to the station to discuss what it's truly like to live and work in space with NASA astronaut Nick Hague, who is currently working aboard the orbiting laboratory.
I'd read astronauts speak about looking back on the Earth and really being aware how insignificant we are in the grand scheme of things. Did you have a similar experience or something different?
You know, that's one of the special things about being up here is being able to float over to the window and see the Earth below, and you can see humanity below you, and you can see it glide by as we go screaming through the sky. And that perspective really challenges you because now you're looking down at everything that you've ever known, all of humanity right there, and you have this deep appreciation for how big the universe really is.
Boeing, NASA, and the U.S. Army conducted exercises for the upcoming CST-100 Starliner missions. This series of mission dress rehearsals at the White Sands Missile Range in New Mexico focus on the landing and recovery aspects of Boeing's Starliner missions. This was one of 3 formal dress rehearsals that took place over the last couple of weeks as part of NASA's Commercial Crew program. Unlike any American-made orbital crew capsule, Boeing's Starliner is designed to land on land and is expected to touch down at one of 5 potential landing zones in the western United States, including 2 at White Sands. Astronauts Mike Fink and Nicole Mann of NASA and Chris Ferguson of Boeing observed a few of the exercises to better understand what will be happening outside Starliner before ground teams can open the hatch and officially welcome them back to Earth. Keep sending in your questions using the hashtag AskNASA. We'll see you next week.
Now check in with NASA TV and nasa.gov at 8 a.m. Houston time Wednesday, September 25th. That's when we'll start full coverage of the next crew launch and docking. The launch itself scheduled for 8:57. We'll be back then at 2 o'clock Central Wednesday afternoon for docking coverage, back again at 4 o'clock for hatch opening when the new crew members enter the International Space Station. This flight is Oleg Skripochka's 3rd long-duration mission, but it's the first trip to space for both of his Soyuz crewmates. NASA's Jessica Meir arrives with years of space station mission training on top of all she learned while earning a bachelor's degree in biology, a master's in space science, and a doctorate in marine biology. And yet, little of that much mattered when she agreed to sit down with us before she left Houston for a barrage of, well, non-technical questions. Take a look.
Clock has started. Roger.
What's your favorite color?
Green.
Favorite book?
Anna Karenina or Galapagos by Kurt Vonnegut.
Favorite song?
Probably anything by The National.
Are you a morning person or a night person?
Definitely not a morning person.
What's one thing you're afraid of?
My plant's dying while I'm on the space station.
Who is the person who makes you laugh the most?
My best friend from college, Jacqueline.
What is something you do outside of work to have fun?
Spend time in the outdoors and nature, hiking, skiing.
What's your favorite animal?
Probably an auk, a seabird, like a murre.
If you could have one superpower, what would it be?
Definitely to fly.
The most valuable high school or college class that you ever took?
My introductory biology class at Brown.
Most important advice you would give to your younger self?
Appreciate and enjoy the moment.
Who inspires you?
My mentor from grad school, Jerry Koyman.
What's a goal you plan on achieving this year?
To fulfill my future plans from my high school yearbook to go for a spacewalk.
If you could spend one day on Mars, what would you do there for fun?
Explore. Maybe some kind of sand dune surfing.
Mir and her Soyuz crewmates will arrive at the International Space Station that has a full complement of bacteria and fungi, because microbes live everywhere, even on the station. Scientists at NASA's Johnson Space Center in Houston constantly monitor the station's microbial environment, and now they're using DNA sequencing to identify the microbes in orbit without having to return samples to Earth for testing. And that's an important step to keep crews and the places they visit safe on future deep space missions. The International Space Station is designed to be a laboratory in space that can provide benefits here on Earth and teach humankind what we need to know to be able to explore beyond low Earth orbit in the years to come, including returning to the Moon in just a few years. A couple of recent experiments are building on all of those goals.
Cementing our place in space. Presented by Science at NASA. As your dog drags you around the block for his morning walk, you're probably not thinking about the wonders of the neighborhood sidewalk. But that concrete is pretty great. Next to water, it's the most widely used material on Earth. In the future, concrete may be equally useful off the planet, when humans construct a permanent base on the Moon. They'll need sturdy stuff that can weather bombardments from solar radiation and meteorites. No one wants a crack in their moon base. The key to making out-of-this-world concrete may be to study it out of this world. 2 experiments have taken place aboard the International Space Station, or ISS, to do just that. the Microgravity Investigation of Cement Solidification, or MICS, and Multi-Use Variable G Processing Facility, or MVP Cell 05. Researchers from Pennsylvania State University and NASA's Marshall Space Flight Center are analyzing the study's results. Concrete is a mixture of sand, gravel, and rocks glued together by cement paste made of water and cement powder. And it's not as mundane as it looks. Under the surface, it's quite complex. What goes on there is key to its strength and durability. Yet scientists still don't understand all the details of concrete's chemistry and microscopic structure. Processing methods aren't cast in stone. There's plenty of room for improvement. Alexandra Redlinska, principal investigator for both experiments, says, "Our experiments are focused on the cement paste that holds the concrete mixture together. We want to know what grows inside cement-based concrete when there is no gravity-driven phenomenon, such as sedimentation. It all begins when water is added to the cement. To put it very simply, the cement's molecular structure changes when the cement grains dissolve." Redlinska explains, as the old molecules dissolve, calcium silicate hydrate and calcium hydroxide start to crystallize. Myriads of these tiny crystals form all through the mixture, interlocking with one another and with the other concrete ingredients, such as gravel. The ISS experiments are researching how this all plays out in space. Redlinska says it could change the distribution of the crystalline microstructure and ultimately the material properties. The ratio of the water-cement powder is critical to making the concrete components combine effectively and determining the strength and durability of the final concrete. Will this ratio need to be different on the Moon, where gravity is about 1/6 of Earth's? That's the kind of question the experiment will shed light on. For the MICS experiment, astronauts added water to a series of packets containing dry cement powder, then added alcohol to some of the packets to stop the hydration process at specified times. For MVP Cell 05, astronauts also hydrated dry cement, but for this experiment, they used a centrifuge on board the ISS to simulate gravity at a number of strengths, including lunar gravity and Martian gravity. For both experiments, the samples were returned to Earth for analysis. "We're already seeing and documenting unexpected results," says Marshall's Richard Grugel, co-principal investigator for MVP Cell 05. Redlinska adds, "What we find could lead to improvements in concrete both in space and on Earth. Since cement is used extensively around the world, even a small improvement could have a tremendous impact. We might even end up with better sidewalks for walking our dogs." For more from the International Space Station, go to www.nasa.gov/ISS-science. For information about other weighty matters, visit science.nasa.gov.
As we travel farther into space, clever solutions to problems like engine part malfunctions will be a vital part of NASA's preparations. 3D printing is an emerging technology that may be used to create custom mission-critical parts. But first, we have to understand how particle shape, size, and distribution affect the manufacturing process. One particular study is helping to explore these factors.
One of the things they're going to have to do for space exploration is do additive manufacturing, because we may have an engine part that fails, and you're certainly not going to take up spare engine parts. You're going to have to manufacture them there. And a lot of what we want to do with that means looking at microscopic particles, because they're building blocks. And now I think a big part of the future in this field, and for lots of different reasons, is active materials. So now we have ways that instead of just the particles being just particles, we can activate them, we can functionalize them, we can get them to associate with one another specifically. So one of the things we're aiming for is active self-replication, evolution in microgravity, to put lots of things together and to optimize properties using evolutionary processes from not living things, but mimicking what living things have done so successfully. We'll learn how to do that on Earth eventually. But before we do that, it's much better, because they have different densities, to do it in microgravity. It's always really important to do something at the forefront of science that will then become a forefront in engineering and production.
Preparing hardware for voyages out into space is only part of the International Space Station's mission of preparing for NASA's future flights of exploration. Scientists are using the station to find ways to protect human explorers from the negative effects of being in weightlessness and from the conditions they'll encounter on long trips to deep space. That includes the galactic cosmic radiation that comes from supernovas.
One of our biggest challenges on a mission to Mars is protecting the crew from radiation. You can't see it, you can't feel it, you don't know that you're getting bombarded by radiation, but we do have operational dosimetry and crew personal dosimeters that we can measure it.
Space radiation comes from three major sources. One is there are radiation particles trapped around the Earth, and they're called the Van Allen radiation belts. The second source of radiation is from the sun. During times of intense solar activity, there can be solar storms and high fluxes of radiation. Protons in particular can reach Earth. The third source of radiation in space is called galactic cosmic radiation, and that's the one that's of most concern for a mission to Mars. The galactic cosmic rays come from exploding stars that we call supernovas.
So I think one of the common misconceptions about space radiation is just how different it is from the type of radiation we have here on Earth. So here on Earth, when you think about sitting down in a dentist chair, they put some kind of lead blanket on your chest to protect you against X-rays. In space, it actually is very different. We don't want heavy materials because it makes the exposure worse. We want things like hydrogen, things like water and polyethylene. The primary reason for that is in space we have particle radiation instead of electromagnetic radiation. Particle radiation is basically everything on the periodic table, hydrogen all the way up through nickel and uranium, but moving at speeds that are close to the speed of light. So thinking about the differences between Earth-based radiation and space radiation, we have a long history and a decent amount of data about the biological consequences of exposure to terrestrial radiation. Where we lack data and we have a large amount of uncertainty is the biological consequences of space radiation. And so really the next steps are, and the ongoing steps are to try to understand those exposures better and the biological consequences that follow them.
At any given time, there are about 300 experiments being conducted on the International Space Station. Just before she left the station to return to Earth in June, astronaut Anne McClain shared her perspective on the research she helped conduct during more than 6 months in space.
The International Space Station is a national orbiting laboratory. Every single day we are answering big questions about Earth and about space, about where we came from and about where we're going. But the other thing that we're doing is we're learning more questions to ask. And so the question really, I think that's important to say is, who are we if we stop exploring? Every day is the intersection of the magical and the technical. Our jobs require a lot of focus, a lot of heads down, detailed work, but there's always moments throughout every day that you step back and you realize, we're working off the planet in microgravity in one of the most unforgiving environments known to mankind. It's really incredible.
In addition to being the hands-on laboratory assistants for science research in space, the International Space Station's crew members use some of their time to share the experience and to help students learn about scientific concepts. Last year, astronaut Scott Tingle released this demonstration video about the importance of nutrition for men and women who are of this planet, if not on it, at the moment.
and welcome to the International Space Station. My name is Scott Tingle. Here on the space station, we live in a microgravity environment, which makes eating here a very unique experience. To stay healthy, we have to maintain a nutritious diet, just like we would back on Earth. Let's go take a look at some of our food and drinks and check out our meal preparation area. During long-duration spaceflight, we have to make sure that we receive enough energy, proteins, and vitamins. Our food lab back on Earth makes sure we get plenty of each as they carefully prepare, test, and package everything. We combine all of this excellent nutrition with exercise to ensure our bodies stay healthy and strong while we're here. We eat 3 square meals a day, just like we do on Earth, and maybe throw in a snack or two. One of my most favorite foods to eat are natural raisins. Here on Space Station, we have to keep our calories up if we want to get all our work done. And the carbohydrates in these raisins really help. And they're kind of fun to eat, too. And how do we stay hydrated in microgravity? With these special pouches. They're filled with water, and we use a straw that has a one-way valve that prevents water from floating out of the pouch while we're not drinking from it. Here's a liquid drink. This is a tropical punch for today. I love drinking fluids on station. Here on station, we have a pretty cool food preparation area. We have a place to get fresh water for us to drink or to put in our rehydratable foods. And we also have an oven to put food in. We pick out some of our favorite foods, chicken fajita for me. Put it in the oven. Close the door and turn it on. In about 15 minutes, I'm gonna have a warm meal. Thanks for exploring a little nutrition with me. I'm gonna send you back to Earth so you can create your very own astronaut menus. See you again soon.
Those demonstration videos are a way that astronauts in space can connect with people on Earth and share the experience. But some astronauts have found other ways to connect their time and space to life on the planet. Recently, one station crew member who was watching a natural disaster unfold on Earth right below him found a way to help.
The first pictures now coming in from Puerto Rico after taking a direct hit. Hurricane Maria slamming into the island. One official saying the island is destroyed.
Hours with winds and rain and didn't stop.
Power lines are down. Streets are impassable. Many roads are flooded.
High winds uprooting trees, overturning cars, and turning buildings into piles of twisted metal.
It is something that will change Puerto Rico forever.
We had no water, no food, no gasoline, no communication at all.
Not knowing where my next meal will come from, it hasn't been easy.
After Hurricane Maria, everything was gray, all the plants were dead. Hurricane Maria took the color away from us.
I am sure that these children will not be the same. They will not be the same. They are still struggling and trying to recover from this.
My name is Joe Acaba. I'm a NASA astronaut of Puerto Rican descent. I was about a week into my mission on the International Space Station. Hurricane Maria was forming up, and from there, if you looked out the window, Maria took up a big chunk of what we could see. It was going to cover the entire island. After the hurricane, their power grid was pretty much taken out. You just couldn't see the island anymore. The hurricane, I think, had a huge impact on, the island as a whole, but especially the kids.
Joe Acaba was our hero, and we need something positive. The students need something positive.
We wanted to pull through, forget all that happened, and
lift up our spirits and lift off the island.
So I knew I couldn't do much from up on the International Space Station, but I did want to connect with the students to show them that there is hope and that there are people out there that care about them.
NASA has the STEM station, which allows the students and teachers to talk to the astronaut in the space station.
It's making that connection so that maybe, they become more interested and we can inspire them more to study the STEM fields.
So we were able to establish and coordinate with NASA one of these video conferences. Thousands of students from different parts of the island watching the video conference with the space station, talking to Joe.
This is Joe aboard the International Space Station. I have you loud and clear. How do you compare?
What is the most impressive view? How did Puerto Rico look?
Are astronauts allowed to visit?
How often? What is the minimum number of?
It was awesome because, as soon as it came up, you could hear people clapping, people were excited. So even though I couldn't see them, I could feel them, and that was pretty neat.
It was amazing. He called from the International Space Station to see how Puerto Rico was doing, and that means a lot for us, a lot.
In May of 2018, I was able to go back to the island, my first time since the hurricane. It was a great opportunity to get out and kind of come full circle with those students, to go and see them in person and, kind of reiterate how important they are and just to give them a little bit more hope because there's still a long way to go on the island.
He's a hero for us. Kids love him and everybody loves him here. Joe Acaba is the role model that we need at this time.
I want to be like him. I want to go far, and I want to be an example for little kids when I'm older.
Not only is the International Space Station a great tool for scientific research and exploration, but for students from Puerto Rico in particular, I think that having that video conference with them, it did provide some hope. It did provide some inspiration. And so it's just one of the benefits that we get from the International Space Station.
If you'd like to get another look at any of these features that we had for you today, check us out on YouTube and Facebook. There are the addresses. And make sure to look around because you'll find lots of other cool stuff about NASA and America's human spaceflight program in both places. And while you're bumping around the interwebs anyway, check out Houston We Have a Podcast. That's folks there at NASA talking about their work in all aspects of space exploration. We post new episodes every Friday. Today, Gary Jordan talks with the next American astronaut bound for the International Space Station. Meet Jessica Meir on today's episode, which you can find at nasa.gov/podcasts, which is where you can also find all of our previous episodes and the full library of all the NASA podcasts, all of which you could also listen to on Apple Podcasts, Google Podcasts, and SoundCloud. This is Mission Control, Houston.